Bismillah. Okay. Okay, this week will be my last lecture for all of you. Okay, next week, next Wednesday, Dr. Prof. Wahyu, he will cover the topic, okay, of kinematics of rigid body. Okay, and the topic that I'm covering today will be the topic of impulse and momentum. Okay, under kinetic of particle. Okay, just would like to highlight here what we have covered so far. We have done kinematics of particle. Okay, we have covered rectilinear, curvilinear, relative motion, dependent motion. Okay, and then we have covered also kinetics of particles. Okay, we have done Newton's second law. Okay, work and energy. And then today, the topic that we are covering is impulse and momentum. Okay, as for the applications, okay, where we can apply this concept is maybe if you are exposed to this experience, we talk about automotive industry. Okay, this is automotive fender, can remove it by using impulsive tools. So we have these impulsive tools. It will deliver a force at a very short period of time interval. Okay, so the issue here is how can we find the magnitude of the linear impulse applied to the fender? Okay, how can we find the magnitude of linear impulse? And secondly is how could we analyze a carpenter's hammer striking a nail? Okay, in the same patient. Okay. So these are the things that we are going to look into. Okay, those applications. Okay. And the next slide, which is slide number 5, is I would like to highlight the definition of linear and linear momentum. This is first thing. Second is what is linear impulse. Linear momentum, this is number 1. Number 2 is linear impulse. Okay. First thing, we look at linear momentum. Okay. For linear momentum, okay, we denote linear momentum as L. Okay, if you see L underscore, this is a vector. So we have vector mv. Mv is called linear momentum, and this vector has the same direction as v. Okay, so the unit of linear momentum is this is mass kilogram times velocity, which is we put together here kilogram dot m divided by s. This is the first one. Second one is a linear impulse. Okay, linear impulse. For linear impulse, there is the integral of force. Okay, we have integral of force. Okay, so integral of force is linear impulse. So we denote linear impulse as the following. Okay, so the way we write linear impulse is okay, impulse. Okay, okay, underscore. Okay, so this is a vector quantity. Okay, this vector quantity measuring the effect of the force, okay, during its time interval of action. Okay, so same thing, we have impulse, It has the same direction, okay, as F. And the unit of linear impulse is Newton time second. Okay. Now we want to look at this graph. Okay. This graph is the graph of force versus time. So this impulse, we can represent it by using this graph. Okay. So from T1 to T2, okay, you have okay, uh, the graph, okay, the graph, and the area under the force versus time. Okay, this is the area under the force versus time is impulse. So we can write this equation. Basically, impulse is area under this curve from T2 to T1. Okay, let's say if the value of F is constant, constant means it didn't go up and down, it goes straight line here. So we can straight away write this equation as impulse, okay, equal to force times T2 minus T1. Okay, this is linear momentum and linear impulse. Okay, this is the definition. The definition. So I want you to familiarize yourself with this definition. So we have linear momentum, and then we also have linear impulse of a particle. Next one, I would like to give you an example. Okay, we do this example. Okay, we want to strengthen the fundamental view related to this concept. The first thing is look at this figure. Look at this figure. We have a truck. Okay, the truck is moving. Okay, is moving with the speed of 100 kilometer per hour. Okay, so what you need to do here is you need to find at this instant the linear momentum of the truck in kilogram meter per second. You see the unit? Okay, you need to follow this unit. Okay, in the problem statement, the speed is given in 100 kilometer per hour. Okay, okay. So you need to convert this kilometer per hour into meter per second. Okay, that is the first thing. Second thing, you need to study this figure carefully. If we put the datum here, this is X and this is Y. Okay, so in which direction the truck is moving? In which direction? It moved to left. It moved to the left, right? So by referring to this datum, it is minus, right? So we start to use, we want to use this theory, the theory of particles linear momentum, which is L equal to mv. Okay, so we start to do the calculation of this one. So we have L, okay, particles linear momentum of the truck, okay, equal to mv. Okay, okay, so mv. M is in kilogram already, so it's 1260 kilogram. Okay, and then the velocity, okay, we have minus 100. Okay, you convert, you divide by 3.6. Okay, and then you get meter per second. Okay, and then you get minus, okay, what would be the calculation? 35,000. How many zero? 1, 2, 3. Okay, which direction? I. And then don't forget the unit. The unit is kilogram times meter per second. Okay, so this is the answer. Okay. The question asks you to find linear momentum. So we use this formula. Okay. So point to highlight, convert, okay, convert from kilometer per hour to meter per second. Okay. Number two, look at the data. Okay. Look at the data. Okay. Which direction is the direction of the velocity? Okay. Third thing, you apply this equation. Okay. Right. Okay. Next one, we go through another example. Okay. This example. This example is a sphere of the mass 750 gram is moving at the speed of 10 meter per second. Okay. 10 meter per second. Again, we have the datum here. The sphere is moving in this direction, so it's going this way minus x, right? And then going up, this is plus y. Okay, see? And then you have to find x and y component of the linear momentum of the sphere in kilogram meter per second. Okay, this is the first one. Second one, you have to find the total linear momentum of the sphere in also the same unit, which is kilogram times meter per second. Okay, so the theory that you are going to use is the same theory, which is particles linear momentum. Okay, which is L equal to mv. Okay, so we start with part A. Okay, so for part A is the x and y component of linear momentum. So we start to find x component. Okay, this is and also for y component. Okay, we can resolve into x and y component. So we do the first one. Okay, Lx equal to mvx. Okay, for Ly. Okay, for Ly equal to mv. Okay, all right, this is the first part. Second, what is the value of m? This one you convert into kilogram. Okay, 1000 gram equal to 1 kilo. Okay, so 750 is 0.75 kilogram. Okay, 0.75 kilogram. Okay, and then how about Vx? We talk about Vx here, going to the left, right? So it's going to be minus 10 sine or cosine? Sine or cosine?
Cosine.
Sine really. Sine.
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 Cos.
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 Cos cosine.
Cos.
Okay.
Cos.
This is cosine 40. Okay. And what is the unit?
AGMS.
Second. Okay. And then how about the one below us? For y component, what will be the value for y component, the velocity component?
10 sine 40.
10 sine 40.
10
Sine 40.
sine 40. Okay. And then meter per second. Right. Okay. And then you compute the values. What will be the first one? What do you get for Lx? What is the value for Lx?
Negative 5.75
Negative 5.75. Okay, what is the unit?
kgm per s.
G kg m per second. Okay, the next one, y component. What is the value? The answer
4.82
4.82. Okay, same unit lah. Okay,
gram per meter second.
all right. Okay, we want to write this time in terms of I and J. Okay, I and J. So we can write Lx. Okay, also can be written as minus 5.75. We write like this. So it's going to be I. Okay, and then kilogram meter per second. Okay, for Ly we can write as 4.82. Okay, which direction? I, J, K?
J.
J.
J, okay.
J.
Okay, J, we have J here, and then the unit is kilogram meter per second. Okay, all right, this is the first part, part A. Okay, now we proceed for part B. All right, for part B, what the question asks us to do? We have to find the total linear momentum. So what does it mean? Total linear momentum? What does it mean?
Resultant.
Resultant for
Resultant force. Resultant force. Okay, any other answer?
Resultant momentum.
Resultant momentum. Okay. So when the resultant, what you need to do?
Tambah lx minus ly.
Okay, so meaning when total momentum, so you need to add up, to add Lx and Ly. Okay, so you add, how to add? We add L, total momentum, equal to Lx plus Ly. Okay, so you can put here minus 5.75 I plus 4. Okay, and then don't forget the unit. Okay, if you didn't put the unit, okay, you cannot get the full mark. Okay, so you put the unit. Okay, now you get the answer. So for part B, right? Is it clear? Do you have any question before we proceed to our next example?
No.
Clear. Everything clear, bro.
Okay, good. Now we proceed to the next one. Okay. Today is a very sunny day, so the sky is clear. Okay. Last one, our last example for this section. Okay, before we take a break. 15.3. Okay, I'll give you a few minutes to read this question. Okay, look at the question carefully. Okay. We have here example 3. Okay, we have two forces applied on the object. This object. Okay, we have this force 1. Okay, this is blue in color. From 0 to 2 seconds, it's going up, and then from 2 seconds to 5 seconds, okay, constant. And then for F2, you have from 0 to 3 seconds, okay, constant, and then start decreasing, decrease from 3 seconds to 5 seconds. All right. And then this is F1 and F2. And then we have the datum here. All right. So same thing. Two forces applied on an object, okay, for the duration of 5 seconds, as shown. Okay. So for part A, you have to determine the X and Y component of the impulse, okay, on the object, okay, during this interval. Okay. Number two, you have to find the total impulse on the object during the same interval. Okay. So what's the equation, the theory that we're going to apply here? We are going to apply this theory. Okay. Impulse 1 to 2 equal to time the integration of force dt time t1 to t2. Okay. All right. We look at the first one, which is part A. Okay. For part A, we have this particle. Okay. We have the data. Okay. Okay. We take this one. This is F. Okay. So what happened here is we have the integration from 0 to 5. F1 dt. Okay. And then this one F2 dt. Okay. This is to respond to this theory. We have these two, right? So we first thing, this is uh, the way we put in the diagram or in the figure. Okay. So we do the first one first, which is X. Okay. So the question asks what will be the X and Y component during the time interval. Okay. So we start with the first one, impulse. Okay. Impulse 1 to 2, and then we take this one X first. Huh? We take the X component first. Okay. Is equal to 0 to 5. Okay. And then F1. Okay. F1 dt. Okay. So meaning this is area under the F1 equal. Okay. So can you calculate for me what will be the area under F1 T curve? Okay, you give me the answer. And then we do similar thing to 1 to 2 for Y. Okay. And for Y, you're going to get same thing, which is 0 to 5 F2 dt. Okay, which is area under F2 T. Okay, F2 T curve. Okay. Okay. Can you tell me what is the answer? Area under X and Y curve? Based on this figure. If you cannot see, I want to enlarge it a bit so you can see clearly. Okay, this is big. Yeah. What do you get? Okay, for 1. This is 1. F1. So F1. Okay. Try to work out. Let me know. You see the chat box whether anybody respond. What is cost? Impulse X3 2.5. Okay. How about impulse Y? Impulse Y? How did they get the response from you? So 32.5. What is the unit? Unit. Okay, Khalidah, Fatul Khalik, Muhammad Haziq. Okay, the unit is, what would be the unit? Don't forget the unit. Okay, Newton second. Okay, how about another one? Impulse Y. What do you get? Impulse Y. 42.5. Okay, correct. 42.5 Newton second. Okay, good. All right. So you must refer to the figure. Okay. Okay, for part B, for part B, for part B, before we go to part B, I think you want to put it in ing. What will happen in ing? So you need to get impulse 1 to 2 x. So you're going to get 32.5 Newton second. Okay. This is plus or minus for impulse in x direction. Is going this which way?
Right.
Going to the right, right? So this is positive, right? I, okay. I Newton. Okay. Then for impulse 1 to 2 y. Okay. How about this one? Going down, right?
Negative.
So we have minus 42.5 J Newton second. Okay. Okay, for part B, simply you just add up the value, the total impulse, okay, for X and Y. Okay, so for B, total impulse on the object during 5-second interval, we're going to get I impulse, okay, 1 to 2, okay, so you add up these two, okay, so you want to get 32.5 I minus 42.5 kg, okay, and don't forget the unit Newton. Okay, we'll take a 5-minute break and then we're going to continue.